Good evening, everyone. Today, I welcome you for this another exciting session on biostatistics, which we have included just to give the variety to this program, which is Envision with BDG. And I hope that many of the participants are not new to this program. They have been attending these programs from a long time. And as this is the 10th session which we are conducting, so under this initiative of Envision with BDG, and I hope that these sessions are really helping you all, and we've jotted down to the topics which are exciting and which have which can give you insights about the latest technologies, which would be really useful for your career. So. The most important thing is, like always, first of all, I will tell you about the company, the BDG Lifesciences, who we are and what we do, and from where we started and what was the reason or what was the motive of starting the organization. And then I will introduce the trainer, or I should say the speaker, Mr. Ishwar Chandra, who will take on the session for today, and then he will continue from there. So, as I would like to introduce you the company BDG Life Sciences, which the full form is Biodiscovery Group Life Sciences. Now, since as you can see, this is a private limited organization, that is, an OPC private limited organization. Hence, before that, this private limited organization came into existence in 2018. However, before 2018, we started the company in 2010, and it was Biodiscovery Group. Now, you might be wondering, people who are new and people those who are not new, they would have been knowing that I have already spoken about that. What was the reason of starting the organization and how it has how it has been helping the young students and the young research scholars. So group is the name which we have added to Biodiscovery because of only one reason. And the reason was that to start off the organization, we have to, the motive of starting the organization is to help. And help to who? To young students and researchers, and those who really don't know that after their bachelor's, like BTech, or even after their masters, what are the opportunities they can get, basically just to give the right guidance. So this was the motive of starting this organization. And till now we are doing it, and we are doing it at a very large scale, because you will see in the coming slide that we have more than 1 million subscribers from all over the world. In the past 10 years we have and this is the 10th year of our organization, so we are celebrating our 10th anniversary also. So what we have been doing is that we have been conducting a lot of workshops, a lot of courses, and research projects, and then consultancy and guiding, and then contract research, so to help you and to guide you so that you can have a much better future. Now, Envision with BDG Life Sciences, this initiative has come up in August 2020. Like I hope I don't know how many of you know about BDG Life Sciences, because we have been conducting online workshops since 2012. But then there are people who, there are organization who started their online training programs in after the COVID-19 pandemic in March. But then we have been doing it since 2012. And previously we used to do free courses, like one free course in 2 months. So this is what we used to do before the COVID-19 pandemic. But then since this is the 10th anniversary, we thought that why not to introduce free courses for the students and for the people who have been connected with us, and just to help it, or just to give it extra to you guys. So we started our in February we started our free courses, and then in March we got this because of the lockdown and everything went online. So we increased the frequency of our free courses, And we also increase the frequency of our online workshops and training programs as well as research projects, so that people should not sit idle, and they should get utilize this time, or because these are really hard times, so that they can utilize these times in developing technical skills like exome sequencing in NGS data analysis, or metagenomics in NGS data analysis, or molecular simulations and dynamics in drug discovery, vaccine design, reverse vaccine immunology, and immunoinformatics. There are a number of programs which we are doing. But then these free courses we have been, we started in February, and then we increased the frequency. This is what I was telling you. These are the free courses. Till now, we have conducted more than 75 free courses, and you would be really amazed to know that more than 14,000 participants from all over the world have participated in that. So why I am telling you all of this, that just to give you a glimpse that how this Envision with BDG initiative has come up. So till August, we have created, we have conducted really a good number of courses, and a large number of people have attended those courses. Then what we thought, that why not to give new, or why shouldn't we start something innovative, because innovation and creativity is the integral part of BDG Life Sciences, and that is the only reason we have been up and running, and being at the top since the last 10 years in the services of bioinformatics and the field of bioinformatics. So that is the reason we thought that, okay, fine, let's do something. We have been doing a lot of free courses. We have done it more than 60 courses. Now let's do something new. Then this initiative of BDG Life Sciences initiative has come up. And in that, what we decided that, okay, fine, we will gather renowned scientists and company professionals and professors from all over the world, and we will ask them to deliver a 1 hour, or basically a 90 minutes, or a 2 hour lecture on their topic of expertise. So this is the reason why we all are here today, and this is the 10th session. And in October we started, and we have got a very huge response, because these sessions are live on our YouTube channel also. So you can, if you have joined today for the first time, then you can subscribe to our YouTube channel and see all the presentations, or all the talks which have been conducted before. And this is what we will be doing till November. And this October and November we have decided that we will be doing. So today is the session on biostatistics by Mr. Ishwar Chandra, and he is the associate professor in Sir M. Visvesvaraya Institute of Technology in Bangalore, India. So quickly, just I'll go through these slides of BDG Life Sciences, and just give you the introduction of who we are and what we are. So basically, we are a guide who will help you in solving your problems. This is what was the motive of starting the organization, because back then until now also, students who are in their final year, they really don't know that what kind of jobs they will get, or whether they will get any jobs or not in the biotech sector. And then they are basically confused that what to do next. So we are a guide to help you, and this is what we have been doing. This is the problem which we identified among the biotech students, especially in biotech students, I should say, that they really don't know that what would be the best for their future. So this is what we started 10 years back in 2009. We created a group, and there we used to share information, and that is how we started helping the young students. So who what we do as a guide, I told you that we are a guide and we will be helping, we are helping you. But what exactly we do? So basically what we do is that we show you the right path, we solve your queries, we give you correct training so to develop your technical skills, and then paving your path for a successful career, and then ultimately giving you launch pad to excel into the field of science. So this is what we are doing, and since 2009 we are doing this. Previously it was, we are doing it on Google groups and Yahoo groups, but then the technology has changed, and then right now we are using Facebook, and most importantly technology has changed, and now we are using Instagrams as well as what's basically messenger platforms. So these are the platforms where a dedicated team of digital marketing, they work, and they help you, they solve your queries, and they try to consult you basically. So that is the main motive of starting biodiscovery group. And as it is in the form of a group, as it is everyone's organization, as it is every people's organization, that is why we have kept group. So when we transformed into a private limited organization, then also we did not remove group from biodiscovery. So now the name is BDG Lifesciences, so biodiscovery group. So group is still there, because it is for students, it is for people who are from biotechnology background and who really have a tough time in knowing that what should they do next, so to have much better job opportunities in future, or as well as PhD opportunities. So this is what we are, and this is who we are, what we do, that as a guide we will show you the right path, solve your queries related to your academics and your career, give you correct training so that you can develop technical skills which are required, which are basically mostly required into the industry currently, so that you can have much better opportunities, then paving your path for a successful career and giving you launchpad for excel into the field of science. So this is who we are. So as I already told you that we started in the form of group, and I have kept this slide just to give you a feel that we are a family. And we are a family that if you will get connected with us, we will keep on helping you. You can ask your questions, and the team is there who will answer your queries. So until unless you do not remove yourself from our groups or from our platforms, we will not remove you, and we will answer your queries, whatever the number of queries you have related to your career. So this is the social service which we are doing since 2010. Since 2009, because we created the group in 2009. Formally, the company was started Biodiscovery Group in 2010. So as I already told you that in 2009, we created a group for students, researchers, and company professionals who were related to the field of biotechnology, bioinformatics, and pharma. So what exactly we used to do back then? We used to provide free consultation. We used to provide tutorials. We used to provide soft copies of the books. Now everyone we are seeing that people are sending PDFs, but then back then 10 years back, it was really hard, it was really difficult. So we had worked really hard and to help you guys. So, and then the most important thing is that we used to provide job offers which are available in India as well as abroad. And then the most important thing, the latest science and technology news, because this is the most important thing. If you are a biotechnology student, or if you are into the field of biotechnology, then you should be on your toes to know that what exactly is happening into your field, because we are into a field which is research. And in research, every single day a new technology is coming up, every single day someone is doing something, so you need to be on your toes to know that what exactly is happening in my field. So that is the most important thing, that is keeping you updated with the latest science and technology news. So as of now, I already told you before, we have reached 1 million plus subscribers as of now. And these subscribers are not only students, but they are company professionals, and they are scientists, renowned scientists from all over the world. So we have a network. Now, this network helps us in connecting people. Like, for example, if there is a scientist who, or if there is a research group leader who wants a PhD, person, we recommend people. This is how we work. If there is someone who is working into the industry and wants a talented person for a particular kind of a job, we connect. So in 10 years, not even a single advertisement of BDG Life Sciences has been advertised by saying that do this program, it is 100% job assurance. No, it's not. It never happens that way. You can't do that. because that is not logical. And that is the reason why in 10 years, whatever the number of advertisements were out of BDG Life Sciences, we have never advertised. However, what we do is that we connect people. Now, this is definitely free of charge, and this is the social service which we are doing. So, we don't charge anything. But then if you are in our network, then definitely we connect with with the people, and that is what connections help, so that you can have better opportunities and you can thrive in your career. So these are some of our subscriber platforms. You could see LinkedIn, YouTube, Twitter, and then these are the current platforms where the participants can inquire, and they can get updates about our programs and what we are doing. Then you could see Messenger, WhatsApp. A lot of people use WhatsApp, so that is why this number is more, that is 62.5%. And then we have Telegram, Google Duo, and BotIam. And then you could see our followers on Pinterest and Flickr, and then we have website subscribers. So these website subscribers, basically we have a dedicated page on our website where you could provide your information, and your information, your details are completely safe, because we do not share the data. That is the most important thing. And you can subscribe to our newsletters, and definitely we help you in sending the newsletters, and then you can get connected with us, and you can ask your queries if you have any. So this was the social work helping part which we were doing. Now definitely we have to run the business. So in 2010 we started Biodiscovery Group, and we started with a program which has led to a situation where it is a win-win situation for both the company as well as the client. So we started with the research project program. Everyone has to do a major project, everyone has to do a thesis project in their final year. So what we have done is that we have launched or started launching research projects on novel topics, means the topics on which nobody else has ever worked before. And these topics are on drug discovery, means latest technology is there. So what you used to get, or still we are doing it, because we have done more than 60 research projects as of now, and all of them have got international publication. So how it is a win-win situation for both of us. For us, you will be paying the fee. Okay, so that is we are winning in that way. But how you are winning? You are winning in such a way where you are getting training first in the technology. Second, you are getting practical application in the form of the research project, means you are getting an opportunity to work on a novel research project. Third, you are connecting with the people from all over the world. And the most important thing is international publication of that particular project by your name. So your profile gets strengthened, and you can have much better job opportunities in future, as well as the PhD opportunities. So the motive of our program, this is the first program which we started. The motive of the program is to create a win-win situation for both of us, plus to strengthen your profile so that you can have a much better job opportunities in future. So this is what we started in 2010, and then we transformed into contract research. Then we started conducting workshops. Then we started conducting online workshops in 2012. Then training, webinar, seminar, conferences, as research projects I already told you about, and internship. So this is what our a wide array of services include. This is what we have been doing: contract research for scientists and the company professionals, as well as research scholars. So I have one slide where I will tell you about contract research. So quickly proceeding, you could, this is the all-time business which we are getting from BDG, at BDG Life Sciences. You could see that the bar of research projects is more, because this program is online as well as on-site. But then since COVID-19 pandemic, it's completely online. Hence, people from all over the world have participated in this, and that is why this bar is the highest. Then we have workshops. We have conducted more than 450 plus workshops around the world. And you name the country: Mexico and Iran and Egypt and Nigeria, Sudan, Kenya, Dubai, Malaysia, Thailand, a number of countries we have been conducting workshops, and then e-workshops. So the e-workshops bar is more because again it is online, so people from all over the world can participate. Then we have courses. Courses, I already told you, these are the free courses. And since COVID-19 pandemic, as we have increased the frequency of the courses, that's why this bar has gone up. And then others include contract research and personalized training. So this is other. So this is the entire business of BDG Life Sciences, what we have been doing. The mission of BDG Life Sciences is very simple. We want to catalyze the process of biomedical sciences into therapeutic technologies that benefit human health and society and eventually fuel the economic growth. So this is the mission of BDG Life Sciences, that to work on new technologies and to contribute to the country and basically economy of the country, and to educate right. That is the most important thing, to educate right or give correct training to the young minds who will be the future of the country. So these are our programs which we have been offering. You could see over here, we have bioinformatics, basic and advanced. Then we have gene and genome editing using CRISPR, Cas9, Cas12a, Cas13a nucleases. And then we have drug discovery, MD simulations, predictive toxicology. A number of NGS data analysis programs are there. In fact, one program that is a 5-day online training in exome sequencing, finding out the genetic diseases between between a family, means father and mother and child. So this workshop, exome sequencing, is starting from 16th of November. So I'll ask my team to send to post it into the chat box so you can take a look. And then this is the this is in 2019 we started artificial intelligence and machine learning and biology, and this has gained a lot of popularity since then, because it's a very unique kind of a program. Then we have immunoinformatics, genomics and proteomics, genome analysis, comparative genomics, in silico molecular biology and genetic engineering, and then agrigenomics, and then cancer, HIV, diabetes, and tuberculosis research. So basically, our research projects are mostly targeted on these 4 diseases, as well as we have been conducting these disease-specific workshops online as well as on-site. So these are our topics in which we are offering our services. Now, this is the most important slide of this entire presentation. And what I would like you to do is just to focus on these 4 words: innovation, ideas, service, and value. So these are the 4 important points, or I should say 4 important words in the sentence, which says that innovation is to translate ideas into service that creates value. And the reason why I am telling you this, that what you will get at BDG Life Sciences or Biodiscovery, which you will not get anywhere else. Why you should come to us? This is the reason. Innovation. We have the most innovative programs, and that is the reason our achievements, the graph of our achievements is still going up. That I will show you in the next slide. Then ideas. We have novel ideas, and then service, excellent services, and creating the value for you so that you can benefit from it. How? First, practical application of technology. Since 2010, whatever the program we have started, everything is practical. It was not limited to PowerPoint presentations. It is not limited to demos, but practical application. Then hands-on training sessions. Hands-on training sessions is the most important thing, because everyone knows that we learn by doing the things. Now, when we know by we learn by doing the things, that we are we know that until unless we will not do, how we will be able to learn. So whatever the program, training programs and workshops which we are doing online as well as on site, they have hands-on training sessions. Then novel research projects. Novel research projects already told you about. And okay. And then result-driven research, because result-driven research is very important for publications. And then everlasting relationship. Everlasting relationship, I have been stressing on this everlasting relationship, because we are a family. And we consider everyone who joins BDG Life Sciences in any of the programs, we consider themselves as a family. And why as a family? Because we want to help, and that was the motive of the organization when we started back in 2009. And it works also in a very positive way, that for example, if a person who has joined us in 2010 for a program, and that person was doing their masters, after 10 years today that person has become a big scientist, or that person has become, has reached to a very high level in a company. He asks that I need someone. Do you have someone? Now recently people have joined us for our research project program. And as they work with us, like these research project programs are of 3 months and 5 months and 7 months. So in these 3 months, 5 months, 7 months, we understand what is the caliber of the person, so we recommend. So when we recommend, this is how we connect people. The same way applies to you. For example, today you join us and you are doing your bachelor's. After 10 years, in 2030, you have become a big scientist, and in 2030 you say that we have a requirement, and we want 3 people for these 3 PhD positions. We will recommend the person who has recently joined in 2030. So this is how we connect people, and this is how we channelize our resources, and that is why this everlasting relationship is very important, apart from helping and solving your queries. So this is the achievements slide which I have been talking about. Now, you all know that if you start with one thing and you do not innovate, then your graph goes up, then it comes to a point where it is saturated, and then it comes down. But then this graph is going up. This means that we have been doing something innovative, and we would have been doing new things and being creative into our methods of trainings and workshops, and that is the reason why this graph is going up. So in a nutshell, what I would like to tell you, that we have 10 plus years of experience in trainings and workshops around the world. 60 plus research projects we have already completed, and that included the design, implementation, completion, and international publication. Then, as I already told you, we have conducted workshops, a lot of workshops, in India as well as in other countries. Then, you could see that we have 50 plus hands-on workshops at premier institutes of India, which included All India Institute of Medical Sciences, AIMS, and then IIT Guwahati, NIT Hamirpur, and VIT Vellore, MMC Madras, JIPMER Pondicherry, etc., etc. And then the most important thing, again, if all the members in the family are happy, then the head of the family is, they are happy, and that is what we thrive on: happy customers. Feedback is the most important point, or is the most important thing in the communication process. Hence, if you start something and do not get the feedback, then that communication process is incomplete. That is the reason when we started our programs in 2010, back then we used to have paper feedbacks. It means we used to have forms, and the participants used to fill up that form. Then we transformed it and directly asked the participants to add to give the feedback on our website. Now we have introduced, means in 2000, since 2018 we introduced video feedbacks, which I don't know that people, other organizations are doing or not, but then we have been doing it since 2018. And that is that the participants record a 1-minute video, or a 60-second video telling us about their experience, and we just post it on our YouTube channel. And people who do not want that their face should come, so they record their voice, and then we make the video, and then that is how we do it. So basically, why I am telling you all this, that the feedback will tell you, if you are joining for the first time, that how our programs, what is the quality of our programs, how the quality of our, what is the quality of the trainers who teach or who give lectures or who conducts the training and the workshops. So that is why this is really important. So just to go through that, we were the first one to introduce online training in drug discovery and designing. We are also the first one to conduct online training in gene and genome editing using CRISPR-Cas9. So this is what we have been, we are the first one. So that is what, if you could see over here, that we were the first one. Now we were the first one. We started CRISPR training, or I should say workshop, in 2017 May. That is May 2017. So okay. So the other thing is that when we, I don't know how many of you know that in 2016 the CRISPR technology was discovered by Jennifer Doudna, and I hope you also know that this year, 2020, the both the scientists, Dr. Charpentier and Dr. Jennifer Doudna, has got the Nobel Prize for this. So in 2016 they have discovered it, and in 2017 May we have launched our first ever training on gene and genome editing using CRISPR-Cas9. So that's how we have been innovating and introducing new programs. This is the free, about the free courses which I already told you about, that we have been doing a lot of free courses, and more than 14,000 participants have participated in our free courses. Then these are the services which we are doing as contract research, virtual screening. Recently we did 2 projects for 2 scientists, one from Coimbatore and one from Bangalore, who wanted virtual screening of antiviral compounds for targets of SARS coronavirus. And the project we've done molecular docking also, and we've done molecular simulations and dynamics also. So this is what we have been doing, then predictive toxicology and ADMET, where we are working on models, in silico models, to predict the toxic, whether the compound is toxic or not, the bioavailability and the bioactivity of the compound, whether it is a GPCR ligand, whether it is an ion channel modulator, whether it is an integrase inhibitor, whether it is tyrosinase inhibitor. So this is what we are doing in this program. And then NGS data analysis, we already told you that there is whole genome sequencing, then there is to find out the SNPs and the SNVs and the indels, that is insertions and deletions. And then we have exome sequencing, metagenomics on 6ts, ribosomal amplicon sequencing, and then we have genome editing using CRISPR-Cas9. So then we have personalized training. This is the last slide. And personalized training is about the program in which we are doing training in specific topics. Now, for example, if you are a research scholar and like for example 8 topics, but then you do not know 2 topics, so what we do is that we you tell us and we design the training program for you, and then we conduct the training program. The next is research project consultancy. Research project consultancy is really important because many times this happens that PhD scholars as well as the master's student, they stuck into their project and they do not know how to proceed and where to proceed. So we design the future course of their project. So that is research project consultancy. And that is all from my side. If you want, you can take the screenshot of this particular slide, and quickly I will now connect with Mr. Ishwar, and you can follow us over here, like Facebook is there, then Biodiscovery Group on Instagram, then Biodiscovery Group on YouTube, then BDG Lifesciences on LinkedIn, and then we have this email address. And for a quick response, we have a WhatsApp number where you can connect with us. So I would like to thank you all for listening and giving your time. And now I would like to connect with Mr. Ishwar Chandra, who will be taking the session for today. And the session is statistical testing of hypothesis in biotechnology. And about Mr. Ishwar, he is working as an assistant professor in Department of Biotechnology, Sir M. Visvesvaraya Institute of Technology, Bangalore. He has completed MTech in Biotechnology in 2011 from Amity University, Noida, BE in Biotechnology in 2009 from BITM Bellary, and he has also completed one-year course on food safety and quality management, IGNO, and is presently pursuing PhD in biotechnology from Riva University, Bangalore. He has 8 research papers published in reputed journal and presented 10 research papers in oral and poster presentation around the world. So he has mentored many projects, and he has active, basically he's actively involved in teaching and all these activities for students, and he is a great speaker. So I would like to connect with Mr. Ishwar. Mr. Ishwar, I'll first of all, I'll just stop my screen and I'll see if he is here. Yes, Mr.
Hello.
Ishwar, please, you can go ahead.
Yes, sir, I'm there, sir.
Sure, sure. Please go ahead.
Can I share my screen?
Yes, you can. So can you please just check if everything is fine? Yes, now we can see your screen, and please go ahead.
Thank you very much, sir, for the introduction, and good evening, all of you. I appreciate that on this time also, so many people are active in learning. And the thing which I'm going to deliver today is related to statistics and biostatistics. And the topic which I've named is statistical testing of hypothesis in biotechnology. You know that mathematics and statistics has lot of application in different disciplines of engineering, and without mathematics proving a certain hypothesis is very difficult and it is highly impossible. So if anybody want to accept a hypothesis or accept a certain statement, everybody want a certain valid backup or a certain kind of proof. So that proof can be generated through statistical data and the analysis of the data. So the learning objective of our today's lecture is basically to understand the procedure of hypothesis testing for larger as well as for the smaller population, and also to learn various statistical tests used in the procedure of testing of hypothesis. So I have kept my agenda very short and clear. I want to deliver, I want you people to understand the procedure for hypothesis testing for smaller as well as for the larger population, as well as to learn some of the statistical tests which are the background or which are the backbone of hypothesis testing or testing of hypothesis, which could be abbreviated as TOH. So there are certain learning outcomes for this lecture today. After this course or after this lecture, probably you might be able to apply the testing of hypothesis for a given data which is obtained from a certain population. And there are certain prerequisites also for this lecture. I expect that the basics of statistics or basics of mathematics are known to the listeners. This is a basic requirement which is required right now. Coming on to the topic directly, the testing of hypothesis. Immediately when I speak about this word testing of hypothesis, you might be having three questions in mind: what, why, and how. That means what is testing of hypothesis and why we use testing of hypothesis. That means why it is required and how to use it. These are the three things comes into the mind when we speak about or when we listen to any topic. Now, what is this testing of hypothesis? Hypothesis testing is a procedure in statistics, in mathematics, whereby an analyst or an experimenter test an assumption regarding a population parameter. Right now, you might be listening certain words which I will be making you to understand in few minutes. In subsequent minutes, you will be understanding certain words. Right now, it is important to understand the statement. What is testing of hypothesis? Hypothesis testing is a procedure. So it's a basically it's a method in statistics whereby an analyst or an experimenter or a researcher test a certain assumption, something which an experimenter is not sure of, regarding what? Regarding a population parameter. Why this technique is used? This technique is used. This technique is used to provide a scientific, mathematical evidence regarding the possibility of a hypothesis that it is true or not. This test provide an evidence concerning the possibility of the hypothesis, whether that hypothesis, whether a certain statement could be true or not, and how it could be done. How can we test the hypothesis? The hypothesis could be tested based on the statistical analysis by measuring and examining a random sample of the population being studied or from a population which is under study. So I hope these three questions are clear: what, why, and how. Moving on to the next thing, before understanding certain words in these three statements, you can observe certain words like population, parameter, hypothesis, random, okay, statistical analysis. You might be wondering what are these terms. I will introduce you to these terms in a few while, but before that it is very important to understand what is statistics, because if you don't understand these things, the later things are very difficult to understand. So as per the American Heritage Dictionary, the mathematics of the collection, organizing, and interpretation of the numerical data is known as statistics, which is done from the population, okay, and obtained through sampling process. There is another definition which says that it's a branch of mathematics dealing with the collection, analysis, interpretation, and presentation of mass of numerical data. Numerical data. So obviously, data is involved here. And I can define biostatistics in my own language as a domain or a discipline which deals with application of statistical methods or tools to a wide range of topics in biological sciences, medicine, dentistry, as well as in engineering. And I can crush this biostatistics into this word COPI, which states collection of data, organizing of data, presentation of data, and analysis of data. Finally, the inference from the data. C stands for collection, O stands for organizing, P stands for presentation, A stands for analysis, and the last, inference from the data. These are the steps in which you start a certain research work. You initiate with collection, then collection of data. Then you move on to organizing the data. Later, you move to the presentation of data. And later on, you analyze the data which you have obtained and organized and presented. And finally, after analysis, you generate a certain inference from the data. And this biostatistics is used in different disciplines. So in front of you, you can see that I have mentioned different applications of biostatistics. It is used in clinical trials of medicine. It is used in genomics. It is used in population genetics. It is used in epidemiology. It is used in personalized nutrition. It is used in phenotyping and various other disciplines. Now, most of the time, people misunderstand the two words, the data and information. These are the two words which look similar but mean different. Data is basically an observation or a value which you obtained when you complete an experiment. Once you conduct a certain experiment or a survey, you take a survey or you perform a experiment in the lab or you go to the field and collect certain observation, it is called as data, which is not yet analyzed. Once you analyze the data, you generate a certain information from that. You generate a certain inference. You try to find out a hidden information from the data. Data itself will not give you any kind of information. Data has to be analyzed to obtain an information. So information is a refined or a curated form of information. You analyze the data to obtain the information. That means you process the data through different statistical methods to obtain information. There are different branches of biostatistics based on the study. If the study involves community health or public health, it is known as health statistics. If you are applying biostatistics in the field of medicine, it is known as medical statistics, which mainly involves identification of genetic defects, estimating the injury, level of injury, the amount of disease, efficiency of a certain drug, or a certain clinical trials on cancer. If you involve all the study, then definitely you are doing a medical statistics. While the vital statistics involves a large population, for the study in order to estimate vital events of births, deaths, marriages, accidents, etc. like this. So there are three fields of statistics: health statistics, medical statistics, and vital statistics. As I mentioned you that there are certain terminologies that everybody should be aware of. The first thing that you should know in the biostatistics is a variable. Immediately when you come across a data, you will be tended to put the data into certain category, either a variable or a constant. Data could be either a variable or it could be a constant. So what is variable and what is constant? Variable is a certain characteristics, it's a certain attribute that can differ from one person to another person, or from one place to another place, or from one subject to another subject, or from one machine to another machine, or from one field to another field, from one city to another city. This is known as variable. A certain characteristic or a certain parameter which varies from one person to another person, like height. Height varies from one person to another person. No two people can have same height. Okay. In the same way, hair color also varies from one person to another person. Eye color, skin texture varies from one person to another person. The weight of a person could vary from one person to another person in a certain population. Now, what is constant? Anything which remains constant, which doesn't change, like p value, like pi 3.141, epsilon value 2.718, gravity. So all these are constant. And if you involve variable in your study, then definitely it is subjected to statistical analysis. And mind it, the constant does not require any kind of statistical analysis because they are permanent. They are not going to change. Anything which is subject to change is liable for statistical analysis. You have to do statistical analysis for it. Now the next term is observation. What is an observation? Observation is a certain measurement that you obtain in a certain event or in a certain experiment or in a certain survey. So it's a value that you obtain after completing a certain experiment. Now data is basically a plural term. It's a plural term. Okay, data is a plural term. Then what is singular term? Singular term is datum. Datum, datum. When a value, a counted variable, counted value, or a piece of information, a piece of data is single value, it is known as datum. And when we talk about set of data, set of data set, when you talk about data set, it is known as data. Means it's a plural which combines lot of values in an experiment, like the birth weight of a baby, a particular baby, only one baby, then it could be termed as datum. When I speak about birth weight of 5 babies or 10 babies, that means I have certain values in my data set. First baby, second baby, third baby, fourth baby, fifth baby, 5 babies are there. So when I talk about 5 or 6 babies, it is consisting of various values. So that's why it is known as data set, and I can call it as a data because it have different values. And datum stand for singular data, single data. I hope I had made a sense and I had made you to distinguish between datum and data. Now, coming on to the important concept in statistics and medicine is the concept of sample and population. In my first slide, where I mentioned you about the agenda of my class, that is learning outcome, I spoke about population and sample. In that sentences, I highlighted words population and sample. What are these population and sample? Population is a group of people, entire group of people, which is under study. Entire group of people means it could be person, it could be things which are measurable, which I can measure. Okay. So it's a group of people, it's an entire group of people. It is known as population. This population could be a population of a city, it could be population of a country, it could be population of a world also. And then what is sample? Sample is a subset of the population. When I take few units from the population, it is known as sample. It may be defined as a part of the population. It's a small part of the population. And what is sampling unit? Each member in a sample, which was earlier the part of a population, is known as sampling unit. Individual person in a sample, from where he has come, he has came from population. So I have picked up few people from the population and formed a group which is known as sample. So sample is a subset of the population. It gives you a blueprint of the population. But why sample is required? What is the necessity of a sample? In many of the experiments, in many of the studies, in many research, it is very difficult sometimes to take the complete population under the investigation. Okay, it is very difficult to perform experiment on each and every individual of a population, especially when the population is very large. And if I don't have time, money, manpower, when I don't have resources to study the entire population, I should go for the sample. So forming a sample is very important. Forming a good sample for your study is very important because sample reflects the population. Sample reflects the population. somebody's mic is on. Can you kindly mute your mic, Ranjit Kumar?
Yeah, I'll just see. I'll just ask. See, participants, please mute yourself.
Kindly unmute only in case if you have any questions or doubt.
Mr. Ishwar, the questions will be addressed after the session, and they have to.
Fine, sir.
Participants number is like 60, so it would be very difficult if people will ask the question. So what we have done is that the participants, whoever have any queries, whoever have any questions, they can type it in the, and then we will take the questions one by one, answer after the.
Sure, sir. Sure, sir. Sure, sir. Okay, so forming a sample from a population is very important because sample is a blueprint of the population. You should form the sample in such a way that all the characteristics or sufficient characteristics or maximum characteristics of the population should be present in the sample. So sample is regarded to furnish the maximum information about a population characteristic or an attribute. In majority of the biological experiments, no two samples drawn from the same population at the same or different times are alike. If you take one sample and if you take another sample from the same population, they will never have the same characteristics at the same time. The process to assess the significance of the difference between two samples drawn from the same population or from a closely related population is called as test of significance. So what is test of significance? It is the process to assess the significance of difference between two samples drawn from the same population. In the previous slide, I have shown you that sample is drawn from a population. Here I have drawn only one sample. If you form another sample from the same population or from a closely related population, both the samples will never have alike characteristics or same characteristics. They will definitely differ in small amount or sometimes in large amounts also. And the process of assessing the difference between these two samples drawn from this population or from the closely related population is known as test of significance. Okay, so what is test of significance? It's a process of assessing the difference between the two samples which are drawn from the same population, whether the two samples are same or not. The results obtained will differ from sample to sample. And this type of variation from one sample to another sample is known as sampling error. This is known as sampling error. First time if you take a sample, suppose this is the sample which you have taken right now. Suppose this is the sample which you have taken right now. Suppose this sample if you're taking, and after this if you take another sample, sample 2, both the samples, sample 1 as well as sample 2 will not be same, they will be different. So the process of assessing the difference between these two samples is test of significance, and the difference between these two samples is known as sampling error. It is known as sampling error. So sample I can also define in a common language. Sample, or I can give an example for this sampling process is when you want to purchase the grapes from a market, from a street vendor. If you want to purchase grapes, how you're going to purchase the grapes from a street vendor? A person who has the bunch of grapes in front of you, How you are going to decide that I should buy the grapes from this vendor or not? By taking samples from it. You will take 1 or 2 pieces of grapes from the bunch. You will taste it. You will, if you find the taste as sweet, then definitely you are going to feel that all the bunch of grapes are sweet. And then you will make a decision that I should purchase the grapes because grapes are sweet based on the sample, 1 or 2 sample. In the same way, in the family, in kitchen, how our mother assess the quality of sambar or dal, how she will assess the quality of sambar or a dal which is prepared in a bowl by tasting a spoonful. What is that spoonful of sambar or dal? That is nothing but a sample. Our mother will not drink the whole sambar or dal to assess the quality. She will take only spoonful. She will mix the bowl, then she will take 1 spoon, she will taste it, and she decides whether the sambar is good or not based on the proportion of salt and sugar in it. If all the proportion of all the masalas are fine, she will decide that sample is good, then definitely the population or the bowl of sambar is right. It is rightly cooked. So then only she will serve to the family. In the same way, sample is drawn to assess the quality of the population. I hope I had made this point very clear. And each time when you taste, if you taste first spoon and if you take second spoon, the taste will not be exactly same. The taste will not be exactly same. So the difference in the taste is nothing but the sampling error. In the same way, if you take first grape piece and if you take second grape piece, they will not be same in sugar content. Both the piece of grapes are not same in sugar content. So there is a chance that first piece of sugar is sweeter and second piece of sugar is not much sweeter. In terms of content of sugar, it might be sweet, but it is not as much sweet as the first piece of grape. So this difference is nothing but the sampling error. I hope everybody has understood this concept of sampling error. So this type of variation from one sample to another sample is known as sampling error. Test of significance obviously helps in determining whether the observed difference between two samples is actually due to chance or the difference is really significant because it is influenced by some external factor. Is the difference in the sample because of chance or it is because of some kind of external factor? So test of hypothesis helps you to estimate these two things. The procedure followed in drawing conclusion from the sample value are included under statistical inference. Actually, statistics has two fields. The first one is descriptive statistics and the second one is inferential statistics. So this testing of hypothesis falls under inferential statistics. In descriptive statistics, we have measure of central tendency, measure of dispersion, which are nothing but mean, median, mode, standard deviation, coefficient of variation, mean deviation, quartiles. All these are central tendency and measure of variation. And we also have correlation, regression, curve fitting under descriptive statistics. But under inferential statistics, we mainly deal with estimation and testing of hypothesis. So testing of hypothesis falls under statistical inference, which is the objective of our learning today. So when population mean is compared to sample mean, what is population mean? What is population mean? Population mean means this population which I'm talking about right now. And what does this mean? Mean is certain characteristic, mean of a certain characteristic like mean height, average height, or mean weight, or mean sugar level, or mean pH level. Okay, mean of a certain characteristic. Mean of population. Population means this population which I am speaking right now, which is indicated as mu like this. And when I'm talking about sample, it is indicated as X bar. It is represented as X bar like this. Okay? It is X bar. And population mean is known as parameter, the characteristics of the population. So whatever the characteristics of population are there, like mean, median, standard deviation, coefficient of variation, quartile, anything, any parameter which is dealing with population is known as parameter, population parameter. And any quality which is related to sample is known as statistic. So this is very important to understand. Statistics. What is statistic? Statistic is the characteristic of a sample. So anything, any statement which involves statistics, it means that it's an outcome of a sample study. It's an outcome of a sample study. And when I'm talking about parameter, that means it's an outcome of a population. So population parameter PP is different from sample statistics SS. Statistics is dealing with sample and parameter is dealing with population. So all the characteristics like mean, median, mode, standard deviation, quartile, mean deviation or coefficient of variation, anything, any characteristics which is related to population is known as parameter. And if you're talking about mean, median, mode, standard deviation, coefficient of variation, quartile deviation, for the sample, it is known as parameter. Sorry, it is known as statistic. Is it clear? I hope I have made a difference between parameter and statistics. So in lot of research paper, you might have heard about this word statistics or statistical study. That means it's a study which is performed by taking sample. Okay, so the procedure followed in drawing conclusion from sample value are included under statistical inference. And when you take the population mean and you compare it to the sample mean, then there are two different assumptions that you are making. One assumption is that both the samples are almost same. That means it will not be exactly same, but there will be some small difference which could be obviously overlooked. And the second assumption is that both the samples are not same. This is the second case. Either the sample could be same slightly or the sample could be different. Okay, so that means they show a significant difference. Significant means indicative difference. Difference between them is obviously due to certain reason. There is a large difference. If there is a large difference between two population, if the mean height of one population is different from the mean height of second population, then definitely there is some kind of reason. If there is a difference between the average height of Indian male and there is a difference in the average height of American male, okay, then definitely there is some kind of reason that is involved. There could be a genetic reason or there could be a phenotypic reason also. So there are two statements involved in this research right now. And the procedure used to establish which of the two hypotheses. So right now, look at this word hypothesis. Hypothesis or a statement. So there are two statements. Either the sample are same or the sample is not same. So these are the two hypotheses which are not sure. It is not yet proved. So both samples are almost same. It is not proved. And the second statement, both samples are not same. It is also not yet proved. So both are hypotheses. So there are two hypotheses right now. So the procedure used to establish which of the hypotheses, which of the two hypotheses is correct is known as testing of hypothesis. Look at this word now. Now we have come to our topic. Now we have understood the meaning of this word testing of hypothesis. It's a procedure to establish which of the two hypotheses is correct is known as testing of hypothesis. Now the same concept I have indicated, I have represented in terms of a diagram. This will definitely give you an idea of a statistical inference. So this testing of hypothesis is concerned with laying down a hypothesis based on estimation from a sample data. Okay, and then testing whether this hypothesis which is laid down is true or not, true or false. So look at this population which I have taken here. So this is the population which is under study right now. Okay, and definitely the characteristic or a quality which we are studying here is known as parameter. Suppose average height we are studying. So average height, average or mean is a parameter right now. If the average is related to population, it is known as parameter. Now to study this population, which is very big, and I don't have time and money to study this population, I will take a small subset of this population, which is called as sample. Okay. And the characteristics, the average height of this sample is known as sample statistics. So this average height of this population and average height of this population is different. Average height of the sample is known as statistics, and the average height of population is known as parameter. And obviously the size of the population is different from the size of the sample, and size of the population is represented as capital N, and size of the sample is represented as small n. To test an hypothesis, you take a small subset of this population, which is termed as sample, and you study this sample of size small n, and whatever the inferences or whatever the outcome you generate from this sample study, or whatever the conclusion you are generating, whatever the conclusions you are generating from this sample study are generalized to this population. Look at this. They are just generalized here. That means they will be applied to this population parameter. That means if you calculate the average height of this sample, you will say that the same average height is for this population also. Okay, so this is known as generalizing the results of a sample to the population. Fine. This is what you are going to do in the estimation and testing of hypothesis. Now to test a hypothesis, I hope I have made a small idea. I have given a small idea for statistical studies on testing of hypothesis. So the test of hypothesis could be done through several steps. There are certain steps that you have to involve to test the hypothesis. Step 1, the basic step, is to define the null hypothesis, to state a null hypothesis. Now I have told you the meaning of hypothesis. What is an hypothesis? Hypothesis is a certain statement which you are testing, which you don't know whether it's a true or not. Certain statement which you know, which you don't know whether it's true or not. It could be true also, it could be false also. Fine. And this hypothesis could be of two types: null hypothesis and alternate hypothesis. The null hypothesis which you are going to define forms the step 1, and the alternate hypothesis which you define forms the step 2. Okay, to understand this step 1 and step 2, let us take an example. You can see a beautiful image of a pond which consists of different flowers, and obviously you can see some kind of fishes here. You can see some kind of fishes. Previous year, you have observed that the average weight of fishes was 20 gram. The last year, that means in 2019, you have observed that the average weight of the fishes which are present in this pond was 200 gram. And this year, you have found that average weight is 180 gram. This average weight, definitely you will find out only through sample. You have taken out few fishes, you check the weight and found that it is 180 gram. Now you want to find out whether this difference, see, you can observe that 180 gram and 200 gram, there is a large difference between these two numbers. Is this number significantly differ or not? Is 180 different from 200 gram? Obviously, if you see the number, it is different. But statistically, is it different? That means this year data, is it different from the previous year data? Whether it is same or it is different is what you are going to check it in testing of hypothesis. Is there any significant difference in the weight of the fishes this year from the previous year, which is 200 gram? So this year it is 180 gram, previous year it was 200 gram. You want to test that hypothesis. And obviously, hypothesis, the main hypothesis will be the null hypothesis, which forms the step 1. So what will be the step 1 testing of hypothesis? What will be the step 1? Step 1 says that there is no difference. Present average weight of the fishes is equivalent to the previous year average weight, which is 200 gram. That means 180 is equal to 200 gram. Okay. So previous year average weight can be represented as mu. You can represent it as mu, and X bar could be 180 gram. Fine. So our step 1 states that there is no difference in the weights of the fishes in this year from the previous year. So mu is equal to X bar. What is this X bar? X bar is the sample weight which you have taken this time. And what is mu? Mu is the previous year weight, which is 200 gram. So historical data is taken as mu. Fine. Historical data, previous year data, that is 200 gram, which is historical data in this research work. So which is taken as mu now. Fine. So this will be our hypothesis. So null hypothesis. Null hypothesis will be always that there is no difference in population parameter from test statistic. What is test statistic? Test statistic is X bar. And what is this mu? Mu is population parameter. Fine. So both are same. You are stating in the null hypothesis as both are same. There is no difference at all. And alternate hypothesis is the reverse of it. Or alternate hypothesis is the negation of that. Ulta, the opposite of that, which states that there is a significant difference in the average weight of fishes this year from the previous year. That means mu is not equal to X bar. 180 is not equal to 200 grams. That is what you are going to state in the alternate hypothesis. Always in a research, there will be two hypotheses. One hypothesis is the null hypothesis, which is the primary hypothesis which you are going to test. If you are failed to accept the null hypothesis, there should be something to accept, isn't it? If you prove that it is not equal, then there should be something to be accepted. What is that? That will be the alternate one. And what is the alternate one? Alternate hypothesis. Null hypothesis is represented as H naught and alternate hypothesis is represented as HA, subscript A, which is effectively the opposite of the null hypothesis. Therefore, I can say that both the hypotheses are mutually exclusive. That means only one of the hypotheses could be true. If the null hypothesis is true, then alternate hypothesis will be false. And if alternate hypothesis is true, then null hypothesis will be false. Either of the one is possible. So that's why I can say that both the hypotheses are mutually exclusive. Either of the one is possible. So the first step is clear, defining the null hypothesis. Second step is clear, defining the alternate hypothesis. Now the third step is defining the critical limit. Critical limit is a certain acceptable limit which you have to consider in a certain problem, and that could be located or that could be searched from a table. What are these tables? These are the statistical tables. But how you are going to search? You're going to search using the confidence level. Confidence level is a certain level of significance, which is also called as p-value, which you consider in your certain research work. That means with what confidence you are proving a certain hypothesis. This confidence could be either 90%, it could be 95%, could be 98%, it could be 99% also. Anyone, any of the one. Obviously, there are others also like 70, 80, 50, 40. But those confidence is mostly not accepted in a research work. And the most accepted value is 95% confidence. What is the confidence? Confidence is certain assurity with which you are saying that the null hypothesis is correct. It's an assurity. Let's take an example. I can assure you that this time my students are going to get 90% marks. I can say this with 90% confidence. So what is that confidence? Confidence is nothing but my assurity. With this much confidence, I am saying that my students are going to get 90% marks. This is the confidence. And when I take confidence in the form of a p-value, it is known as level of significance. What is a p-value? P-value is represented as 0.1, 0.05, 0.02 or 0.01. If I take confidence as 90%, confidence as 90%, I will just mention here percentage, confidence of 90%, then level of significance is 10%. 10% means 10 by 100, which is equal to 0.1. In the same way, if my confidence is 95%, it means that level of significance is 5%, and the p-value will become 0.05, which is 5 by 100, which is 5 by 100, which is nothing but 0.05. In the same way, if the confidence is 98%, then level of significance will be 2% and p-value will be equal to 0.02. In the same way, if the confidence is 99%, my level of significance will be 0.01, which is the p-value. And for these confidence, I should assign certain table value. If you search these confidence or level of significance values in a statistical table, you will come across certain values. What are these values? Z values, or a probability distribution value. I will rather call it as probability distribution value. This is the critical limit. This is the critical limit that you have to take for your study. These are the critical limit value which you have to take for your study. And how can you find out this? You can find out from statistical tables, provided you know the confidence of your study. Either confidence, or you know the p-value, or you know the level of significance. Either you should know confidence or you should have a p-value in your study. You can search for Z value or probability value from a certain statistical table. Z value means probability value, which is the critical limit. Okay, this is not exactly a particular Z value. They can be T value also, which is T table value, and Z value means Z table value. That means it has been obtained from the table, Z table value. Same way we have T table value if you are using T test. Now, what is this T test and what is this Z test? You might be wondering. This is what forms the step 4 to estimate the test statistic, and this is the heart of the problem. It is based on appropriate probability distribution. It is based on an appropriate probability distribution. What is this probability distribution? Probability distribution could be Z table value, Z distribution. It could be T distribution. It could be chi-square distribution. It could be F distribution also. Fine. And these are known as probability distribution, which is selected based on certain cases. What are these cases? We will learn in a few minutes. And if you are using Z distribution, then obviously you should refer Z table value, which I can write as Z tab value. If you are using T distribution, if you are using this T distribution, then you should have Z table value, which I'll write as Z tab. So here you will not have Z value, you will have T values. And if you are referring chi-square distribution, then you should use the chi-square table value. Chi is represented like this, slightly like X, chi-squared value. And these are the values for Z table value. These are the Z distribution value. If you are using T distribution, then obviously T tab value will be different. These are not constant. These values will differ based on what distribution you are applying in your research work. Fine. In few minutes, I will mention you what is the technique, why you will go for Z value, Z table, why you will go for T table, why you will go for chi-square, and why you will go for F test value. What is the background of selecting the test, either Z test, T test, F test, chi-square test, whatever the tests are there, probability distribution are there, how to select the appropriate test. In a few minutes, I will mention you that also. After performing step 4, which is estimation of test statistic, you will compare in the step 5. What you are going to compare? The test statistic value, which is abbreviated as TS. Test statistic is TS, that is calculated value. Whatever you are going to calculate from Z test or T test or chi-square test or F test, whatever the value you are going to calculate, you're going to compare it with the table value. What is the table value? Table value is found in step 3. Fine. If you're calculating Z value, you will refer the Z table value. If you are calculating T distribution, you will refer the T table value. If you are calculating chi-square distribution, you will refer the chi-squared table value. I hope I am making a sense right now. Once you compare test statistic value with the critical limit, you should observe whether the test statistics is greater than or lesser than the calculated value. Look at this. Whether test statistic is lesser than the critical limit, or test statistic is smaller than the critical limit. Whether test statistic is greater or smaller than the critical limit. Based on that, you will come to the step 6, which is making a statistical decision. This is the important step. This is where you are going to make a decision. What decision? Whether to accept or reject the null hypothesis. Fine. Whether to accept or reject the null hypothesis. That is what you're going to make a decision based on the step 5. Now, how you're going to make a decision? You are going to accept the null hypothesis if the test statistic value, that means calculated value, if the calculated value is lesser than the critical limit or the table value. Kindly make note of this. If the calculated value is smaller than the table value, you are going to accept the null hypothesis. If the calculated value is greater than the critical limit, then obviously you are going to reject the null hypothesis. If you reject the null hypothesis, then obviously you have to accept something. What is that you are going to accept? You're going to accept alternate hypothesis, which you have also stated in step 2. Is it clear? I hope these steps are clear. All these 6 steps are clear. And the final step, the step 7, is inference. What is the inference? You're going to deliver, or you're going to write the statement which you have mentioned in the hypothesis. Whatever the hypothesis you are going to accept, the same hypothesis you are going to deliver, or you're going to write in the inference. Suppose if you accept the null hypothesis, then you are going to write the statement which you have stated in the step 1, the null hypothesis here. Whatever you have stated here, you're going to write in the inference. If you accept the null hypothesis, if you reject the null hypothesis, then the inference will be step 2. In step 2, whatever you have defined, that statement you are going to Right in step 7, you're going to deliver the statement which is mentioned in either null hypothesis or in alternate hypothesis. I hope all the 7 steps of testing of hypothesis are clear. Okay, I hope all the 7 steps are clear. Let me just go back and recall you once. So the step 1 is stating the null hypothesis. You're going to state the hypothesis which you are studying, or whichever you are testing, which you don't know whether it is true or not. Second step is alternate. So reverse of the null hypothesis is alternate hypothesis. Step 3 is defining a critical limit. That is the table value that you are going to obtain based on the confidence that you are putting in your research work. If you are doing the research with 98% confidence, then you're going to take a certain table value from statistical tables. Okay. Step 4 is test statistic, estimating the test statistic. This is the core of the problem. Here you are going to calculate a test statistic based on different probability distribution. What are the probability distribution? Either Z test, T test, F test, chi-square test, ANOVA, or anything. One-way ANOVA, two-way ANOVA, T test, Z test, or chi-square test. There are a lot of different tests that you are going to use. Fine. So this is known as calculated value or test statistic. Step 5 involves comparing the test statistic or calculated value with the critical limit or with the table value. You're going to compare the calculated value with the table value. If the calculated value is lesser than the table value, you're going to accept the null hypothesis in step 6, where you're going to make a decision, valid decision. If at all the calculated value is greater than the critical limit, then you're going to reject the hypothesis. And finally, in step 7, you're going to deliver the statement. Whatever hypothesis you have accepted, the same hypothesis you're going to put it on inference. So these are the 7 steps for testing of hypothesis. Now, to understand this concept in a better fashion, I have brought some kind of small numericals in front of you so that you can understand this topic. Now let us start with the first test, which is Z test. Now I have mentioned you several names of the distribution like Z test, T test, F test, chi-square test. You might be wondering why there are so many distributions. There are so many distributions based on different cases. In a simple language, I can say that these cases are originating because of different conditions. And in brief, I can say that based on the size of the sample, based on the size of the sample. Right now, you can understand that based on the size of the sample, different tests are employed. There are majorly 2 types of sample, large sample and small sample. I hope everybody can see the screen in front of you. There are 2 types of samples. One is large sample and the second one is small sample. If the sample size is greater than 30, the sample size is greater than 30, it is known as large sample. And if the sample size is smaller than 30, it is known as small sample. Fine. So this is the main factor that distinguish between Z test and T test. The first 2 tests which I mentioned you. In most of the research, either you will be dealing with Z test or T test. If the size of the sample is lesser than 30, you are going to use T test. If the size of the sample is lesser than 30, you are going to use T test. And if the size of the sample is greater than 30, you are going to use Z test. Fine. So when you are going to use Z test is used for large sample. That means N is greater than 30. Anything greater than or equal to 30 is called as large sample. If you have large samples, then you are going to use Z test. If the size of the sample is greater than 30, large samples, sorry, smaller than 30, that means small sample, small sample, you're going to use t-test. Okay, and under t-test also you have two cases, paired t-test and unpaired t-test. Paired and unpaired t-test, that we will come to uh, understand that later. But right now, try to understand, make a point that if size of the sample is lesser than 30, t-test is used, and if size of the sample is greater than 30, you're going to use z-test. So this is the distinguishing factor between t-test and z-test. And paired and unpaired t-tests are used when there are two groups of samples and one group is related to before and after studies. In certain experiments, you will record the observation before giving certain input, and you will also record the data after giving certain input, like the heart rate or blood pressure before drinking the coffee and after drinking the coffee. What is the effect of coffee? You record the blood pressure before drinking coffee and after drinking coffee. If there is a difference is there in the heart rate or blood pressure before giving an input, what is the input? Drinking coffee. So here you have two sets of data on the same patient. One is before the giving input and one is after giving the input. So this is known as before and after study. Okay, so when you have before and after studies in the experiment, you use paired t-test, and obviously it will be done on small sample size lesser than 30. Paired t-test, fine. Like headache before taking medicine and headache after taking medicine, whether it is reduced significantly or not. Is there any difference or not? If it is reduced, then definitely it is because of the medicine that you have eaten, with whatever the medicine you have consumed. Fine. So when you have before and after data, it is known as paired t-test. Fine, because it is done on the same patient, but one set of data is before giving medicine and one set of data is after giving the medicine or after giving the input. The second is unpaired t-test. Here we have two sets of data from two different population or from two different samples. Unpaired, name itself indicate unpaired, they are not paired. That means there are two sets of samples here. Fine. This type of studies is mostly done on agricultural field and also in clinical trials, where you give one medicine A to one sample, and second medicine B to the second sample. There are two samples. Each sample consists of 10 subjects, 10 members. So the first sample will be given medicine A and second group is given medicine B. Fine. And you will be testing which medicine is more effective, whether medicine A is effective or medicine B is effective for a certain problem. Like for weight loss, you're studying a weight loss and you have two sets of people, sample A and sample B. You give first medicine to first set of people and you give second medicine to second set of people. Fine. And you check in which group the weight reduction is more. Just a second, give me a second. So we'll try to find out which drug is more effective in weight loss. Okay, so here you have two sets of sample. One is sample A and another is sample B. Fine, and both the samples are different. The people in sample A are different from people in sample B. So there are 10 different participants, fine, which are contributing voluntarily for the weight loss study to find out which medicine is more effective. This is known as unpaired t-test. And the third type of test that you will be practicing is the chi-square test. The chi-square test. What is the chi-square test? Chi-square test is a test which is applied when you have certain data related to theoretical and experimental results. Sometimes you can predict some data using using some formula. You can predict that this could be the result. But when you conduct the experiment, the experimental data will not coincide with the theoretical theoretical data. Fine. When you have this set of data, such type of data where some kind of theoretical data is there, which is obtained by applying some formula, and there are some kind of experimental data, that means when you conduct the experiment, you get the data which is not exactly equal to the theoretical data. In such conditions, you are going to use the chi-square test. So chi-square test is used when you have two sets of data. One set of data is theoretical, which you can predict using some formula, and experimental data is the data which you obtained after conducting the experiment. So such type of data set, if it is there, you are going to apply chi-square test. Fine. So these are the three important tests that you are going to encounter in day-to-day life, in day-to-day experiments. These are the most common statistical distributions: Z, T, and chi-square distribution. And under T, you have paired and unpaired T test. Okay. So I will try to show you some kind of problem. When you are testing certain hypothesis, when you test a certain hypothesis, there could be two conditions. There could be two conditions. What are these conditions now? Conditions are when mean is available in the problem or proportion is available in a problem. What is this mean and proportion? Mean of a certain value is given in the problem. Mean of a certain characteristic is given in a problem. So there are two conditions. So the first condition is when mean is given, and the second one is proportion is given. When proportion is given. Mean means average of certain characteristic, like average weight is given, or average height is given, fine, or average concentration of glucose is given, okay, or pH is given. Some average value is given in the problem, or you are studying the average of certain characteristic. Proportion means the percentage. When you are studying certain percentage, when you are studying certain percentage of characteristic, like percentage of COVID positive people in Bangalore, or percentage of diabetic people in a certain country, or percentage of cancer patients in the Karnataka, fine, or percentage of lung cancer patients in New Delhi, fine. So percentage means a certain proportion means the percentage is given in a problem. You are studying some kind of percentage. Mean means when you are studying some kind of average in a research work. Okay, you could be either studying average, or you will be interested in determining certain proportion. So these are the two conditions. And under each condition, you have certain cases. Certain case. What are these cases? When you have single mean, that means you are taking only single sample, only one sample, which you do most of the time. And sometimes you also take two samples. So you call it as two means or comparison of mean. So this is the condition. This is the case, two cases. The first case is single mean, second case is two mean. In the same way, under proportion also you have two cases. So the case one is single proportion, and the second case is comparison of proportion or two proportion, when you have two samples in your research work. I hope everybody has understood this. So in each of the case, we will be seeing some numericals here. Let's take the testing of hypothesis for single proportion. Okay, single proportion. Fine. There is a problem in front of you. In a sample of 1,000 people in Karnataka, 540 are wheat eaters and rest are rice eaters. Can you assume that both wheat eaters and rice eaters are equally popular in this state at 1% level of significance? This is the problem. This is the problem we have to test. So what do you have in a problem? You have a sample of how many people? 1,000 people in Karnataka. 540 are wheat eaters and rest are rice eaters. So what are the rest? 1,000 minus 540 are the rice eaters. Can you assume that both wheat and rice are equally popular? Are equally popular or not? At 1% level of significance. Look at this term. This is very important. At what? 1% level of significance. So I have given a certain confidence. Level of significance is 1%. That means 0.01. So my confidence in the problem is 99%. I have to test the hypothesis with 99% confidence. I should be able to say with 99% confidence. Fine. So the step one is laying down the null hypothesis, which is H0, which is both wheat and rice eaters are equally popular. That means the proportion of wheat eaters and rice eaters are same. It is 0.5, 0.5. So alternate will be, it is not equal. Both rice eaters and wheat eaters are not equal in the Karnataka. So that is my alternate hypothesis, which I'm going to lay down. Next is to find out critical limit. Critical limit. What is the critical limit? I am going to determine from the table value. What is that? That is equal to 2.58. How I have obtained this 2.58? By referring the statistical table. To refer the statistical table, I require a level of significance which is given as 1%. At 1% level of significance, if I hunt in the statistical table, it will be equal to 2.58. But why I have used this Z test? You might be wondering. Z test is used because sample size is more than 30. How much it is right now in the problem? 1,000. Sample of 1,000 people. So obviously I have to use Z distribution. So what is that? Z table value, Z critical value. Z table value is 2.58. Fine. So once I calculated the Z table value, the next step is to calculate the proportion. What is a proportion? So proportion of the wheat eaters is 540 out of how much? 1,000. So it is 540 divided by 1,000, which is equal to 0.54. Fine. This is small p. Fine. This is small p, which I have obtained now. 540 are the wheat eaters out of 1,000 sample size. Fine. Now I will calculate the test statistics. Test statistic, that is Z calculated value I have to calculate. And I will use this formula. Z calculated value is equal to small p minus capital P divided by under root of PQ by N. You might be wondering from where this problem, formula has appeared. Okay, this formula has came from the Z calculated estimation process. This is the standard formula that you have to apply when you are using Z distribution. It's a standard formula. Fine. So this formula will be constant. It will remain same when you are using Z table value. Fine. So Z calculated value is equal to small p minus capital P divided by under root of PQ by N. Now what is this small p? Small p is the calculated value which you have obtained here, 0.54, and this capital P is 0.5. What is this capital P? Capital P is nothing but proportion. What proportion? Proportion of wheat eaters and rice eater which you are stating in the problem. How much you are stating? It is same 0.5. It is same 0.5. So that's why P will capital P is equal to 0.5 now. And everything is under modulus like this. I have not written here modulus, but this modulus will come here like this. Fine. So after substituting all this, PQ, what is this PQ? Capital P, capital Q, capital P is 0.5 and Q is 1 minus P. So P plus Q is equal to 1. P plus Q is always equal to 1. So once you substitute P and Q value 0.5, 0.5, you will arrive at this number which is equal to 2.532. This is the calculated value. Now this calculated value has to be compared with the table value. What is the table value? Z table or Z alpha value. And what is that Z table value which you have calculated? It is equal to 2.58. Now you can observe that this calculated value 2.532 is lesser than the calculated value, sorry, lesser than the table value. What is the table value? 2.58 and calculated value is 2.532. 2.58, 2.53. 2.53 is lesser than 2.58. So obviously you should accept the null hypothesis. You should accept the null hypothesis. What is the null hypothesis you have stated? Both wheat and rice eaters are equal. Both are equal. Why they are equal? Because you have stated, that's what you have stated. Percentage of wheat eaters, 50%. Percentage of wheat eaters and rice eaters in Karnataka are same. 50% are wheat eater, 50% are rice eaters. That is what you have stated in the null hypothesis. So once you accept the null hypothesis, you have to state, you have to write down the same hypothesis. You have to state the same hypothesis which you have stated in the null hypothesis. What is that? Both wheat eaters and rice eaters are equal. That means 50% are wheat eaters and 50% are rice eaters. This is how you're going to solve when you have single proportion, single sample. Fine. There is another example in front of you. 20 people were attacked by the disease and only 18 survived. Will you reject the hypothesis that survival rate if attacked by this disease is 85%? In favor of the hypothesis that it is more at 5% level and also obtain 95% confidence interval. So since the confidence interval, estimating the interval is not the agenda of our study, we are not going to deal with this. Our only intention is to test the hypothesis. Fine. So oh god, time is running. It's already 9:57. So I will right now I will skip this problem. I will do the next problem, which is testing of hypothesis for difference of proportion. Now, if you have two samples in front of you, in the previous problem, I had only one proportion in front of me, one sample in front of me. If I have two samples in front of me, what I'm going to do? Let's take this problem. In two large population, look at here. There are two large population. Now I have two samples in front of me. There are 30 and 25%. In two large populations, there are 30 and 25% respectively of blue eye people. That means there are 20 and 25 blue eye people in two different populations, population A and population B. In population A, how many are blue eye people? 30. In population B, we have 25 blue eye people. is this difference likely to be hidden in sample of 1200 and 900 respectively from the two populations? So one size, what is the size of first population? It is 1200. And what is the size of second population? 900. Is this difference significant or not? In first population, we can find 30% of blue eye people. In second sample of 900 size, we can find 25% blue eye people. So blue eye people are different in both the population A and population B. Now look at here. You have two population. You have two proportion. First proportion is 30 and second proportion is 25. Size of the sample is 1200 and size of the population second one is 900. You have two samples now, two population here. So P is to N is to, and same way you will have two Qs, Q1 and Q2. So what will be our hypothesis? There are two hypotheses. First hypothesis, the null hypothesis, is difference of population of blue eye people is not there. There is no difference. Difference of population is likely to be hidden in the sample. It is hidden. There is no difference at all. It is hidden. Fine. And alternate hypothesis I can define as reverse of it. It is not hidden. There is no there is a difference is there. Fine. Difference of population is not likely to be hidden in the sample. Fine. Next step, level of significance, critical limit. Critical limit is 1.96. How? Because level of significance is 5%. If level of significance is 5%, I can calculate this 1.96 from the table value. And why I am referring Z table, Z distribution? Because the population size is larger. How much it is? 1200 and 900 people. Fine. So when I substitute this formula, when I use this formula, when I have two proportions, I am going to get the calculated value which is equal to 2.5538, while the table value is 1.96. So what I'm going to do? I am going to reject what? Reject the null hypothesis. See here, I have rejected the null hypothesis. Why? Because calculated value is greater than the table value. Table value is 1.96. Table value is 1.96. Calculated value is 2.55, which is greater than the table value. So that's why I will reject the null hypothesis and I'm going to accept the alternate hypothesis. What is alternate hypothesis? Difference of population is likely to be hidden in sample. So whatever the question is given in the problem will be taken as null hypothesis, and reverse of it will be taken as alternate hypothesis. So the proportion of blue eye people are different in population 1 and population 2. Fine. So in the same way, we have this problem of this is a second problem which I will leave for you to study more. And in the same way, I will have mean also. In the previous two problems, we were focusing on the proportion of certain characteristic, proportion of the wheat eaters, right eaters, or the proportion of certain disease. Fine. Now, in the case of mean, I will be focusing on the average of certain parameter. Look at this example. An insurance agent has claimed that the average age of policy holder who insure through him is less than the average age of all agent, which is equal to 30.5 years. A random sample of 100 policy holder has been taken, which has the mean age equal to 28.8 years and standard deviation is 6.35. Test his claim at 5% level of significance. So level of significance is given. and some average age is given. See here in the problem I am discussing about mean. What is that? Average age or mean I am discussing. And what is the size of the sample? It is greater than 30. So it is a Z test which I am going to use now. Fine. So let us start with first, that is stating the null hypothesis. Null hypothesis is average age of the policy holder who insure through him is less than the average age for all the agents. This is what we are going to test in the problem. This is what is given in the problem. Same thing we are going to take it in the null hypothesis. Alternate will be reverse of it, and critical limit will be calculated using table value. And Z calculated value is calculated using this formula, which is equal to 2.67. And this is greater than the table value, which is 1.96. So what you're going to do, you're going to reject the null hypothesis. You have rejected the null hypothesis. Right? So this was the single mean. In the same way, you also have two means also, where there'll be two samples. Like in this case, the mean height of 50 male students who showed above average participation in college event was 68.2 inches with a standard deviation of 2.5 inches. So this is our first set of people, 50 male. And in the second case, I have another 50 male students who showed no interest in such participation, gave the average height of, what is the average height? 67.5 and standard deviation of 2.8. Test the hypothesis that male students who participate in college athletic event are taller than the other male students. This is the test. This is the hypothesis we have to test. So that is what we are going to write in the null hypothesis. There is no significant difference between the student participating in athletic event, those who are interest, and those who don't have any interest. Alternate will be reverse of it. Okay, that means there is a difference is there, difference in height, average height is there. Then you are going to calculate the critical limit from the table. Finally, you are going to estimate the calculated value, which is equal to 1.38, and you're going to compare these two. Since you see that the calculated value, which is 1.3, is lesser than the table value, you're going to accept the null hypothesis. Fine. So there is no significant difference in the students participating in the athletic event. Fine. Those who have interest and those who don't have interest. So there is no difference in that. This is how you are going to test the hypothesis using Z test. Fine. Using the Z test. Coming on to the T test, which I mentioned that it is for small sample. Since the size of the sample is smaller, we are going to use the T test. And there are two types of T test, paired and unpaired T test. Paired T test is used when you have before and after study. Look at this example, which is there in front of you. A random sample of 10 young men was taken and the heart rate was recorded. Heart rate of the people, of the young man. How many young men? 10 young men. See here, 10. See now the size of the sample is small. Earlier we had 1000 people, 900 people, 500 people. Now suddenly size of the sample is reduced. It is 10 now. 10 young men. So obviously we should use T test. Fine. The random sample of 10 young men was taken and the heart rate of the of the young man were recorded or measured. Before and after taking the cup of caffeinated coffee, the results are below. So before taking coffee and after taking coffee, which coffee? Caffeinated coffee. Is there any difference in the heart rate? For the first patient, before taking coffee, it is 68, and after drinking coffee, decaffeinated coffee, it is 74. Second person, it is 64. After taking decaffeinated coffee, it is 68. You can see there are certain differences. There are 10 patients. All these are 10 people. What is the difference? Is there any difference or not? To test that, you should adopt the same procedure. First, you will lay down the null hypothesis. What will be the null hypothesis? There is no difference in the heart rate. Heart rate before drinking caffeinated coffee and after drinking caffeinated coffee is same. There is no difference at all. Alternate hypothesis will be there is a difference is there. Fine. Critical value is table value which you obtain by referring this 0.05 level of significance. Fine. You will calculate the table value. Which table value? Not Z. This time it will be T table value because you are doing T test. Why you are doing T test? Because size of the sample is lesser than 30. Fine. So you will have T table value. And similarly, you will calculate T tab value, T table, T calculated value. How you are going to calculate T calculated value? Using this formula. Using this formula. T calculated value is x bar minus mu divided by SD under root of n minus 1. Fine. And you will get this value of 2.4. Now you can see that this 2.4 is greater than the table value. What is the table value? 2.58. So once you see that table value is greater or lesser than calculated value, accordingly you will take decision. So in this case, calculated value 2.4 is greater than the table value. So obviously you will reject the null hypothesis. You're going to reject. Fine. And you're going to accept the alternate hypothesis. What is the alternate hypothesis? There is a significant difference. There is a significant difference between before data and after data. That means there is an influence of coffee on the heart rate. Is it clear? There is an influence of coffee on the heart rate. That's why before and after data is different. In unpaired data, you have two sets of data again, but one set of data is control data and second set is treatment data, or something like drug 1 is given and drug 2 is given for the second population, second sample. This is sample 1 and this is sample 2, but both the sets of people are different. These are the 10 different people and these are the 10 different people. In the earlier problem, only one set of people were there. Only 10 people, and on the same 10 people, before the data is recorded and after the data is recorded. But here in the case of unpaired t-test, you have 10 different people here. This is one group, one sample, and this is 10 group of people. Fine. So you're checking the heart rate or heartbeat. When coffee is not given, this is placebo. Placebo means when the coffee is not given. And in the second group, to all the 10 patients, coffee is given. This is the heart rate. Is there any difference of the coffee on the heart rate? You have to find out. So to the group which you have not given drug is known as control or control or placebo. So to this group, first group, you are not giving coffee and you are recording the heart rate. To the second group, you are giving the coffee and you are recording the heart rate. Fine. So your hypothesis will be there is no difference in the heart rate between the control and treatment. So both the groups have same heart rate is the null hypothesis. Alternate hypothesis will be there is a difference in the heart rate. Fine. Critical limit, next step. Critical limit you should find out from the table, and calculated value should be calculated using this formula. In each case and in each condition, the formula is changed. This is the average heart rate of the treatment group, and this is the average heart rate of the control group. This is the pooled standard deviation, and N1 is the size of the first sample, N2 is the size of the second sample or second group. Fine. Pooled variance is calculated using this formula, which I have mentioned here. Right now, because of the limitation of time, I am unable to solve the problems in detail. I can only show you right now. So you can calculate the pooled variance and substitute here, and substitute the mean heart rate, average heart rate for control group and average heart rate for treatment group. That means to group which you have given the coffee, and you can calculate the calculated value. Calculated value is 2.86 and table value is 2.10. So what you are going to do? Table value is smaller than the calculated value. Calculated value is greater than the table value. Since calculated value is greater than the table value, you are going to reject the null hypothesis and you are going to accept the alternate hypothesis. What are you going to reject? You are going to reject the null hypothesis, which states that there is no difference. No difference means both the heart rates are same. It means that there is no influence of coffee. And what is the alternate hypothesis? Our alternate hypothesis is there is a significant difference in the heart rate. So which indicates that coffee is having an effect on heart rate. So which hypothesis you are accepting? You are accepting alternate hypothesis. You are accepting alternate hypothesis, which says that coffee has effect on heart rate or pulse rate. Is it clear? So this is how we test hypothesis in case of paired t-test and unpaired t-test. Coming on to the last test, which is chi-square test, which I mentioned you that it is applied when two sets of data are there. What are these two sets of data? One is the theoretical data which you obtained by applying some formula, and the second set of data is experimental data which you get after performing the experiment. So the formula for chi-square test is observed value minus expected value raised to power 2 divided by expected value will give you chi-square calculated value. Fine. So I will explain this concept with a small problem. In a health awareness campaign, the number of boys and girls are expected to be equal. So now what is the expected value? The participation of boys and girls is equal. You are expecting that it is an equal participation. But out of 100 participation, after 100 participants, 60 are girls and 40 are boys. Test the hypothesis that boys and girls are equal in number. So what is your anticipation? Your anticipation is that equal number of boys and girls should be there. But on the day of health campaign, 60 girls comes and 40 boys comes. Proportion is different now. Fine. So your observed data is girls is 60 and boys is 40. But what is expected? Expected is that equal number in an awareness campaign, health awareness campaign, number of boys and girls are expected to be equal. Expected data is 50%, 50-50%. But theoretical data means expected data. Observed data means experimental data. That means on the day of event, 40 and 60 is the proportion or the percentage of male and female candidate. So you will apply this formula, observed minus expected divided by expected. So once you apply this formula, so 40 minus 50 square divided by 50. What is this 40? 40 is the percentage of boys minus 50. This is the expected data. This is an expected data. Fine. This is the first one. Then second, for girls, how many girls? 60 girls. How many it was expected? 50% divided by 50. So we'll get this chi-square calculated value as 3.81, and table value will be equal to table value. Once you hunt for the table value, okay, you will get certain table value. I think in this problem right now I have not indicated. Suppose the table value is 3.51. 3.51 is the table value. Now you can observe that the calculated value, no, sorry sir, table value is given here. I have calculated. Fine, it is 3.81. It is 3.81. Fine, and calculated value is 4. You can observe that calculated value is greater than the table value. Now you have to reject the null hypothesis and accept the alternate. What is the null hypothesis you have stated? Null hypothesis is observed data, that means experimental data is equal to theoretical data. The number of people appearing on the day of event, on the day of health campaign, is equal to the expected data. What is expected? 50-50 participation. It is equal. An alternate hypothesis is it is not equal. So you are going to accept the alternate hypothesis because calculated value is greater than the table value. So therefore, you are going to infer that the number of boys and girls participating in the event are not equal. Boys and girls participation is different. Fine. Let's take another example, very important example. In an experiment with pea plants, okay, chickpeas plant, it is observed that 300 round and yellow, 130 round and green, 118 wrinkled and yellow, 32 wrinkled and green are obtained. According to the Mendel theory, Mendel hereditary theory, the number should be in the proportion of 9:3:3:1, which is the outcome of a dihybrid cross. Is there any evidence of difference from the Mendel law at 5% level of significance? So a person has conducted the chickpea experiment. He has found that round and yellow are 300, and there are 130 round and green plant, 118 wrinkled and yellow pea plant, and 32 wrinkled and green pea plants are coming out. But actually this character, what character? Round and yellow, round and green, wrinkled and yellow, wrinkled and green should be the proportion of 9:3:3:1. So what is a Mendel law? It's a theoretical data. It's a theoretical data. And what is the experimental data? This is the experimental data which you have obtained by conducting the experiment. So you calculate the experimental data and match it with the theoretical data. You will get the calculated value as 7.8, which has to be compared with the table value, and table value is equal to, say suppose table value is 7.9. Table value is 7.9. Now you can observe that calculated value, which is equal to 2.47, and table value is 7.8. Calculated value is smaller than the table value, which is 7.8, isn't it? Calculated value is smaller than the table value. So now what you have to do? You have to accept the null hypothesis. What is the null hypothesis you are stating? You're stating that the experimental results are coinciding with the Mendel law. They are following the Mendel law. There is no difference. The experimental results are not different. They are equal to the, or they are in line with the Mendel's law. There is no difference. Experimental results are equal to the Mendel law, whatever the Mendel says, 9:3:1. It is equal. So that is what you are going to accept. Fine. So the outcome of the experiments are in the proportion of 9:3:1 will be the inference of your result, inference of your data. This is how you are going to generate inference from the study. Is it clear? So for time being, I think I have moved beyond the time, and I wanted to show some more material to you. I don't think, because shortage of time is there, I will not be able to continue right now. So if you have any doubts, you can ask. So my lecture is concluded.
Thank you, Mr. Ishwar. It was a really nice session. And however, yes, the subject is such that we it requires a lot of time, and definitely we cannot cover it up in the time which we had. But then still, we still have seen a lot of examples, especially on the chi-square test. So it's really great. However, we have got a few questions here as well as on YouTube. So I would just quickly go through them one by one, and then you can please answer, and then we will close the session for now. Okay. Mr. Ishwar, are you there? Can you hear us? Just hold on, guys, please. Mr. Ishwar, are you there? I don't know what's the problem, Mr. Ishwar. He can't hear me. Maybe he has just taken a break. Yes, yes, yes. Everyone is asking for the feedback link, but we need to finish the session, right? I don't know why you guys are in a hurry that you just want the feedback link. And is it only for the certificate you guys attend this session, or it is for learning? I don't know what exactly the problem is. Everyone is asking for the feedback link, feedback link, feedback link. At least hold on for some time. We are having a question answer session, and once that question answer session will be done, you will get the feedback link, because you should know, right, that what are the questions that are asked and what are the answers that needs to be answered to those kind of questions. Yeah, you will get the feedback link, you will get the certificate. It's but I don't know, but how it is, is it only about the certificates? I seriously don't understand. So just hold on for a while, and I'll just quickly make a call on his number and see if he has left the meeting, or like I don't know what exactly. So just hold on, please.
Hello. I'm audible, Asif sir?
Yeah, Mr. Ishwar, yeah, we were trying to connect you, but then I think you just went for a break. So, what we are trying to do is like we will just quickly take up a few questions. There have been a lot of questions, but I don't think so. There is time to answer all the questions, and
Okay.
people are really worried about feedback link. So,
Okay, sir.
I have to do something for that. We have to discuss
Okay.
something.
Okay.
So,
In between, my net connection got disconnected. I don't know where it got disconnected, where I ended. I
yeah, yeah.
hope I.
Take some questions which were asked. So the first question which I would like to take is please what is the utility of ANOVA test? Can you hear me?
Hello. Yeah, sir. I can hear you, sir.
Yeah, so
Hello.
the first question which I would like to take is what is the
Ha, sir.
utility of ANOVA test?
Okay, sir. ANOVA test is used when ANOVA basically means analysis of variance, sir. There are two types of analysis of variance, and the first one is one-way analysis of variance, and second one is two-way analysis of variance,
Okay, so
which are
basically
some.
the variance test, right?
Yes, sir. This
Okay,
is the test is used when you are studying the differences in the variance of two or three population. Like in t-test, you have two samples. If you go beyond two samples,
more
if you
than
have four,
samples.
sir, if you have more than two samples, like four samples or five samples, it is practically difficult to apply t-test because each time you have to take two samples and number of t-tests will become more. So if suppose you have four samples in front of you and you have to study the difference in four samples, if you apply t-test, you have to apply t-test three times by taking two samples each time.
Okay, okay, okay.
In case of analysis of variance, sir, you can study all the four samples at the same time, sir. You can study the differences,
That's
the
great.
variance of all the four samples at the same time.
Okay, okay, okay.
Ha, sir.
So
And this is a test which is employed mostly when you are dealing with agriculture related experiment.
okay, okay,
So
okay.
agricultural field will be divided into four different parts, and
Mhm.
in each part you will be studying certain parameter like yield. In one field you will be studying yield of rice, in another field you will be studying yield of wheat,
Okay.
another field you will be studying wheat of some other crop like that, sir. The effect of fertilizer on the yield of four different parts, or sometimes eight different parts you will be studying, sir.
Okay, that's great. So the next question is, what is the sample size limit for chi-square test?
Sir, okay, sir, it can go beyond anything, sir. It could be anything. It could be 5, it could be 10, it could be 16, or it could be 100. Like in pea plant experiment, actually
Mm-hmm.
you could observe that some 800 pea plants are round and green and 15 are round and yellow, like that numbers will be given.
Okay.
So there is no limit for the sample size in case of chi-square test.
Okay.
The application of chi-square test should be done only when the data reflects nature. Like one set is experimental data and another set is theoretical data.
Mm-hmm.
Like gravity, like if you want to test the difference in gravity, so I can perform an experiment and find out the gravity right now, and I also have a standard gravity value also, sir, with
Okay.
me, which is 9.81. And
Okay.
if I calculate, I might not get exactly gravity equal to 9.81. It might differ 9.3, 9.4.
Mm-hmm.
So to test, is my calculated value different from the standard value or not,
Okay.
I am going to use the chi-square test, sir.
Okay.
When I repeat the experiment to find out gravity several times, it could be done 5 times, it could be done 10 times, it could be done 1,000 times also, sir. So
Okay.
sample doesn't have limit in applying for chi-square test. The
Okay.
case or condition is very important to note, sir.
Okay. So the other thing is that they are asking that okay, can you please type in one or two book for biostatistics which are suitable for the life science students? Maybe in the
Sir,
if you can.
sir. Fundamentals of Biostatistics by Veer Bala Rastogi.
Okay, good.
VB Rastogi. Fundamentals of Biostatistics by Veer Bala Rastogi is one good book that can be referred. And there is another book, Statistics, Basics of Biostatistics by Khan and Khanam. That is also one good book where more of the problems are from agriculture related experiments, sir.
Okay, okay, okay,
Khan and Khanum, Fundamentals of Biostatistics by Khan and Khanum. And
okay.
there is one standard statistics book. It is not biostatistics, but statistics book, which is known as SC Gupta.
Yeah, SC Gupta,
SC Gupta,
I
yeah,
haven't
many
been.
people refer that, sir.
Yeah.
And the problem are not related to biotech. They are common problem. You can see some life science related problem also,
Yes, yes.
but mostly on financial related problems are there. And I can observe that in Veer Bala Rastogi, many of the data is taken from SC Gupta, but only context of solving problem like life science concept is involved in Veer Bala Rastogi. Even
Oh,
in Khan and Khanum also, some of the problem, some data is from SC Gupta.
okay. So the last question of this session, because we've exceeded a lot of time, is can you throw some light on level of significance, like in layman terms?
Okay, sir, level of significance is uh, estimated or it is uh, decided. It's basically a decision that we have to make in a certain research. This decision you are going to make based upon the confidence, sir. How much, with what confidence you are saying a certain hypothesis. Sir, in statistics, nothing is sure. Nothing is sure. Everything is associated with certain probability. So it's
Yes.
a probability value. It's a p value, probability value. Level of significance is nothing but a p value, probability value, which is always associated with the statistics. You are going to project something. After 10 years later, this is going to happen. After 10 years, this lunar eclipse is going to happen, this solar eclipse is going to happen, or this COVID-19 is going to repeat after 100 years. I can say that, sir. I can test by taking the data and doing the statistical analysis. I can say, but I cannot say simply like this. It has to be backed up with certain confidence. With certain confidence. What is that confidence? It could be either 50%, it could be 70%, it could be 80%, it could be 90% also, sir. So
Okay.
based upon the confidence, I am going to take a certain probability value. If my confidence is 99%, then my p value will be equal to 0.01. If my
Oh,
confidence is 95%, my level of significance will be 0.02, which is 2%. So
yes.
98, 100 minus 98 is 2%, which is level of significance 2%. 2 by 100 is 2%, which is equal to 0.02. P value will be 0.02. So confidence and level of significance go hand in hand. If
Okay.
you know confidence, you can you can decide level of significance, sir.
Okay.
It
And
differs from research to research.
just come up that can we try chi-square test more than two or three specimen at a time?
Exactly, sir. We can, sir.
Okay, so Mr. Ishwar, thank you very much for your nice session, which was really informative. I'm really thankful to you on behalf of the BDG Life Sciences family, as well as the participants who have given their valuable time in attending this session. Now, participants, this is especially for you. We have sent the feedback.
Always welcome, sir.
Yes. So participants, we have sent the feedback form link into the chat box. You can click on the link and provide the your valuable comments. And this feedback link, as you all know, that would be valid only till 1 p.m. tomorrow India time. And your certificates will be sent in 2-3 days. So please have some patience, and you will, if you have given your feedback, then definitely you will get the certificate. So thank you very much, and keep learning from BDG Life Sciences. Feedback link, we will post it again. No issues. That should not be an issue. It has been posted again. And just go through the website of BDG Life Sciences for upcoming workshops and upcoming sessions, so that it will be helpful for you, so that you can learn in a much better way. And we have topics. So the upcoming topics, there are 2-3 more topics that are upcoming. And the future of drug design, in silico drug design, this is a topic which is a very interesting, and it would be delivered by Dr. Hassan from South Korea. And then we have bioinformatics session again on a huge demand. So we are very happy to to Mr. Ishwar, and thankful to Mr. Ishwar that he has given taken out time from his very busy schedule. So thank you very much, Mr. Ishwar, and thank you all the participants. Thank you very much. See you soon for the next session.
Thank you very much, sir. You're always welcome. It is difficult to solve mathematics related concepts online. I have tried my level best to give the concept in the simplest language as possible, sir. I hope people have understood the concept of testing of hypothesis and they will be able to apply. If in future anybody want to test any